Ask Shaima to join again because of some technical problem, uh, she was removed from the meeting. Yes, anybody give the response, please. Whether she is trying to join. Okay, let me start the discussion now. Yeah, yeah. Today's topic is branch and bound technique. This is one more algorithm design technique. So here you can compare this general plan of this branch and bound technique with the backtracking technique also. So you may identify some similarities between these two techniques and the differences also. So for very first word or the first sentence about the branch and bound technique is it is an improvement of backtracking technique. So I think the idea of backtracking technique is clear. So in the backtracking technique, we are exploring the current node based on the available choices. And whenever we reach the dead end, we have backtrack the complete process. So it means go back to the previous stage where you have taken the previous decision and change the decision and again explore the current node. So you repeat this process until you reach the solution. Okay, that is what the idea of backtracking. But branch and bound technique, it is an improvement over the backtracking technique. It means that in branch and bound also, whenever a non-promising node or a dead end is occurred, you have to backtrack. Okay, backtrack. But what is the improvement here? For every node which you are going to explore, we are going to embed a bound value. The bound value may be a lower bound value or upper bound value. For every child node, we are embedding that bound value. So based on the bound value, the promising paths will be decided. If the current node value is not better than the bound value, then we are going to treat that path as a non-promising path, and that will be terminated there itself. So that is what the improvement made on backtracking technique, and that improvement is called as a branch and bound technique. So both the techniques works similarly, but bound value, I will explain you later what is that bound value and how to calculate the bound value. So two types of bound value, lower bound and upper bound value. It depends on the problem. That bound value calculation is absent in backtracking but present in branch and bound. So the bound value will decide in which path we have to continue in searching the solution. Okay, so hence, branch and bound strategy is applicable to optimization problems. So this is one more point you should remember. I think you know the meaning of optimization problems. Optimization problem is the problems where we are required to give the optimal solution. For example, like knapsack, traveling salesman problem, and job assignment problem. So all these examples we have already discussed in brute force also. You know what is the time complexity of solving these problems in brute force? It takes too much of time. It's not the best method to solve these problems. These problems are called as the optimization problems because there we need to give the optimal solution, the best solution available, best solution. Okay, so now I'm going to solve these three problems: job assignment, knapsack, and traveling salesman problem using branch and bound technique. Okay, so in today's class, we will discuss one example, that is a job assignment problem. Okay, so I think now you came to know what is the meaning of optimization problems. Okay, so next, in the next line, what I'm explaining here is the main idea of the how the state space tree is constructed in branch and bound technique. Okay, so for each node, that is each node is called as a partial solution of a state space tree. Okay, for every node, we have to compute the bound value. Compute the value for every node. Computes a bound on the value of the objective function for all the descendants of the node. Descendants means child nodes of the current node. Okay, so calculate the value, compare it with the bound value. If it is not better, then it is a non-promising node. Choose the another one. Okay, so now the we are using that bound value to decide whether the node is a promising node or non-promising node. I have already explained this one. See, promising node means if you explore that node and that path, if it leads to the solution, if there is a maximum chances are there to get the solution, then that node is called as a promising node. Non-promising node means the node which is not taking you to the solution. That path is not a not promising path to reach the solution. That node is called as a non-promising node. Whenever you reach the non-promising node, terminate the path. Okay, no need to waste the time. Okay, this is what the beauty of the branch and bound technique. Okay, so the bound value will guide you in searching the state space tree, searching for a solution in a state space tree. Okay, so there is a very important thing is finding the bound value or calculating the bound value. Okay, now let me to explain one example under this branch and bound technique. I think the general idea is clear now. General plan of branch and bound technique. You may get clear idea when I solve one example under branch and bound technique. So very first example I am considering for today's class is assignment problem. There is a job assignment problem. Problem statement you already know the job assignment problem statement. N people were there and N jobs are there. So we have to assign jobs to N people such a way that one job to one person. Okay, so that the total cost of the assignment is as small as possible. That is what the problem statement of job assignment. What are the constraints here? One problem should not be assigned to more than one people, or more than one people should not be assigned to a single job. So it is one-to-one assignment. Okay, those are the constraints. With satisfying these constraints, we have to assign all n jobs to means we have to finish the assignment with cost of the assignment is as small as possible. Okay, so we are expressing this problem in terms of cost matrix. The cost matrix contains n rows and n columns. So let me take one example. You will get the same type of example in the exam also. It is the means the problem is expressed in terms of cost matrix. You can observe here. So here I have one. Let me to hide this. Okay. So now total 4 persons A, B, C, D, and 4 jobs are there. You can observe the cost matrix here. Take the rows. Person A 9, 2, 7, 8 is there. 9 means if I assign job 1 to person A, cost will be 9. If I assign job 2 to person A, cost is 2. If I assign job 3 to person A, he takes 7 days to finish the task. That is what the meaning of cost here. Okay, or you may take it as how much money he takes to finish the task also as a cost. Okay, if I assign job 4 to person, he will take 8 days to finish the task. Okay, that is the meaning of these numbers. I hope the problem is clear now. Okay, so now I am going to find a optimal solution to this problem such a way that I want to finish all the n jobs with less cost. Okay, now we will solve this problem using branch and bound technique. So my suggestion here is while you are listening this class, it's better you take one sheet of paper and pen and do the calculations also. I will give sufficient time and I have done the calculation in this presentation also. To get clear idea, it's better you also do the calculation. Okay, after finishing the presentation, if you have any doubts or if anything is wrong in my solution, you can arise the queries later. Okay, so it's completely depend on the calculation. If you do any mistake in the calculation, you will get a wrong answer. Okay, so the idea is first thing, as I told you, in branch and bound technique, we have to calculate the bound value. Okay, first I will explain you how to calculate the bound value. Okay, so the idea to calculate the bound value, the idea here is select one element in each row of the cost matrix. Okay, cost matrix C, so that no two selected elements are in the same column. That is one thing, and their sum should be minimum. Let me to repeat this one. If you are assigning a job to a person, you have to understand these two conditions. One is no two selected elements are in the same column. See, when you observe the cost matrix, columns means what? Jobs. So no, you are not supposed to take two elements from the same column. If you are taking two elements from the same column, means you are assigning the same job to two persons. It is not allowed. It violates the problem constraint. There is one thing. And whenever you assign the job to the persons, the cost should be minimum. Okay, remember these two things. Okay, now let me explain how to calculate the bound value. See, I am going to call this bound value as a lower bound value. The reason is I want to produce a solution to this problem as a optimal value, and that optimal value should be minimum. Hence, the bound value is called as a lower bound. For some problems, the optimal value may be maximum. Then you have to calculate the upper bound value. For example, like knapsack, I want the maximum profit there. Okay, fine. For this problem, calculate the lower bound value. The method to calculate the lower bound value is very simple. In every row, initially, in the very beginning, this is the method of calculating the lower bound value. In every row, you select the smallest number. Okay, in the first row, the smallest number is 2. Second row, the smallest number is 3. Third row, the smallest number is 1. And in the fourth row, the smallest number is 4. Okay, you add these numbers, you will get the sum as 10. So now 10 will be the lower bound value. 10 will be the lower bound value, and you will not get a solution. You will not get a solution which is lesser than 10. Hence, it is called as a lower bound. Okay, so at least you may get 10, or you can't get a solution to the problem which is lesser than 10. Is it clear? Calculating the lower bound value. I hope it is clear. Or let me to repeat once again. Okay, to calculate the lower bound value, in every row, choose the smallest number and add those numbers. The sum will be the lower bound value. Okay, fine. Okay, now you can observe the cost matrix 92786437. Okay, 5218 7694 is the cost matrix. Okay, so as I told you, to calculate the lower bound value, I am going to take smallest number in every row. In the first row, smallest number is 2. I have taken. Second row 3, third row 1, and fourth row it is 4. You may have one doubt. You may ask a question. Before explaining the lower boundary value, what I told you, no two elements should not be from the same column, correct? But here, to calculate the lower bound value, I have taken 3 and I have taken 1 from second row and third row respectively, correct? Okay, you observe here both 3 and 1 are in the same column. Okay, what I told you in the beginning, the value should not comes from the same column. But here I have taken 3 and 1 from the same column. Yes, it is allowed only when you are calculating the lower bound initially. In the very beginning, while you're calculating the lower bound, you can choose the smallest numbers. Even they are from the same column also, you can choose. Even all the in all the 4 rows, if the smallest numbers are in the same column, in column 1 only, yes, you can choose. It is allowed only in the beginning. It is allowed only in the beginning. Please mute.
Excuse me, sir.
Yes.
Sir, can you please zoom out the presentation, sir, a little more?
Zoom out. Why it's not visible?
It's visible, sir, but at the down part we can't see, sir.
Okay. I will take that part later. Okay. Hmm?
Okay, sir.
Okay.
Okay.
Or I will try to zoom it out. Okay, now. Is it okay now? Is it okay?
Yes, sir.
Now you can view the down part, no? The subtree.
Yes, sir.
Okay, total 5 nodes are there. Can you see the last level also?
No, sir. Only 4 we can see, sir.
No, it's, what I'm asking now, in the last level, 4 nodes are there. 1, 2, 3, 4.
Yes, sir, we can see that.
Okay, okay, fine. That's what I required. Okay, fine. Thank you. Uh, Fine. So now calculating lower bound value is clear. Okay. Now, so in the very first step, the value what you have calculated, the lower bound value, start with that node. That is the very first node or a root node of the state space tree. You can observe in this tree, start I have written, okay, and I have given number for the node also. It is 0, and in that node I have written LB. LB means lower bound. Lower bound is 2 plus 3 plus 1 plus 4. The sum is equals to 10. Okay. So now this is current available partial solution. Okay. Now I am going to explore this node. To explore this node, I have 4 choices. Means I'm going to start assigning the job to first person first. Okay, person A. Okay, to assign job for person A, I have 4 choices. I can assign job 1 to person A, or job 2 to person A, or job 3 to person A, or job 4 to person A. So I have 4 choices. So I have created 4 child nodes for the starting node. Okay, you can observe them. Node 1, 2, 3, 4 respectively are generated by assigning job 1 to person A, okay, job 2 to person A. You can see the assignment there. Okay, in the node I have written job 3 to person A and job 4 to person A. Okay, assignment is done. Okay, but for every assignment we have to calculate the lower bound value. Okay, now let me to calculate the lower bound value for the first node. Okay, LB equals to, see, the very beginning lower bound is 10. Now we are going to generate the lower bound value which is maybe equal to 10 or more than 10. Okay, so now observe the node 1 clearly. Clearly listen my explanation. You observe the lower bound value. It is 9 plus 3 plus 1 plus 4 equals to 17. Okay, so it means that you are assigning job 1 to person A. If I assign job 1 to person A, what is the cost? It is 9. Okay, 9 plus, see, in your original equation replace 2 by 9. Okay, 9 plus. Now for the remaining 3 persons, you as usual you continue with the selecting the smallest number in the remaining 3 rows. Okay, now let me to explain clearly. I am assigning job 1 to person A. Cost will be 9 plus. Now person B, person C, person D, we are not yet assigning, but to calculate the lower bound value we are considering those 3 persons also, and the cost what I need to consider for the remaining 3 persons, no, smallest number in the next 3 rows. Okay, now let me explain this one. So 9 is, I think 9 is clear now. Why I have written 9 here? Because I am assigning job 1 to person A plus. Now for person B, I have to take the smallest number from the second row. What is the smallest number? 3. Yes, you can take 3 plus person C. Smallest number is 1. Yes, write 1. And person 4, smallest number is 4. Yes, it's correct. What is the sum? 17. Okay. Next, this is one possible solution. Okay, it may be a promising or non-promising. We will decide it later. Suppose if I assign job 2 to person A, what will be the lower bound value? So if I assign job 2 to person A, cost will be 2, 2 plus, and for the remaining 3 persons, person B, smallest number is 3, person C, smallest number is 1, person D, smallest number is 4, and lower bound equals to 10 now. Okay, I hope it is clear. Now let me to take or assign job 3 to person A. If I assign, see, I'm taking all the possibilities. Okay, if I am assigning job 3 to person A, what will be the cost? Cost will be 7 plus, now see, node 3 is very important. Here you have to listen carefully. I am assigning job 3 to person A, cost will be 7 plus what I told you for the remaining 3 rows, you have to take the smallest number in the next 3 rows. Okay, but here for person A I have written 7. For person B, smallest number is what? Actually it is 3. Correct? Yes, it is 3. but 3 is in the same column where I have chosen 7. I hope you are following. 3 in the second row, smallest number is 3. 3 which comes in the same column where I have chosen 7. It means that I am assigning job 3 to person A. So you are not supposed to take any smallest number from the third column for the remaining persons. I repeat the sentence. Once you are assigning job 3 to person A, you are not supposed to take the smallest number for the remaining 3 persons from the third column. Okay, so hence for second person B, I am going to take the next smallest number. What is the next smallest number other than 3? It is 4 now. Yes, you can take 4 now, plus and in person C, smallest number was 1, but 1 is coming in the third column. No, so leave 1, take the next smallest number. It is 5. And person 4, smallest number is 4. No problem. 4 is in the fourth column. No problem. You can take 4. Add these 4 values, you will get 20. Okay. Now let me explain how node 4 is calculated. Suppose instead of giving job 3, if I give job 4 to person A, what will be the calculation? If I give job 4 to person A, then the cost will be 8 plus. Okay. And now what I need to do, I have to choose the smallest number for the remaining 3 persons. Okay. And those numbers should not comes in the fourth column now. Okay. Let me to verify for person B. For person B, smallest number is 3. Oh, 3 I can take because 3 is not coming in the fourth column. Because fourth column is given for person A. Yes, I can take 3. 3 plus, what about person C? Yes, 1. You can take 1. Person D, you can take 6. Yes. Now see here. I have taken 4 till now for person 4. Now it is changed to 6. Why? Because 4 was the smallest number. I agree with that. But 4 is coming in the fourth column. No, fourth column is given for person A. So I should go for the next smallest number, that is 6. Yes, you can take 6 now. Now the lower bound becomes 18. It's a very important calculation. Okay, what I have explained till now. Uh, if you have any doubts, you can ask me later. So let me do the calculation. So for node 1, lower bound is calculated. You can observe here LB equals to, I have written C1 comma 1 means first number represents the row, second number represents the column. 1 comma 1, 2 comma 3, 3 comma 3, 4 comma 4, and the cost will be 17. Second node calculation is also given in the slide. Third node calculation is also given. Fourth node calculation is also given. C represents cost matrix, where the number 1 comma 1 or 3 comma 2 or 3 comma 3, 4 comma 2 represents first number represents row and second number represents the column. Okay. I hope the calculation is clear. Now the next part in this solving this problem is, from the available 4 options, choose the best one. Which one is best with respect to the cost? First node cost is 17, second node cost is 10, third node cost is 20, and fourth node cost is 18. Now I am going to choose the second node as the best node. So I am going to treat the remaining 3 as non-promising nodes. Is the branch and bound concept is clear now? 1, 3, 4 are considered as non-promising and 2 is considered as a promising. The reason is, always I want to give the cost with a minimum value. If hence, among these 4 possible partial solutions, second node is the best solution at present. Okay, so now I am going to treat node 2 as the promising node. Next, I am going to explore node 2 now. Okay, so once I start exploring the node 2, one job assignment is fixed. What is that? Job 2 assigned for person A. It is fixed now. So you are not supposed to assign any more job to person A, or you are not supposed to assign job 2 to any other persons. It is fixed now. Okay, now I am going to explore node 2 in the next slide. Okay, now listen here. So again, for your reference, I am showing the cost matrix which is required for the calculation. Now you can observe this state space tree. So here I have taken a part of the state space tree. Node 0, I have taken start node. And I told you node 2 is, I am going to take it as the promising node. So I have taken only node 2 here, and I'm exploring node 2 now. See, when I take node 2, one job is fixed already. Job 2 assigned for person A. Now what are the possible options now for the next person? Next person is person B now. Now I have to decide which job I can assign for person B. So for person B, I have only 3 options left, because job 2 is already given for person A. Now the options left for person B as B are, I can give job 1, or I can give job 3, or I can give job 4. So I have created 3 nodes now. Those node numbers are 5, 6, 7. Okay. If I assign job 1 to person B, what is the cost? If I assign job 3 to person B, what is the lower bound value? If I assign job 4 to person B, what will be the lower bound value? That I have to calculate. Okay. In this slide, I have done the calculation also. I will show you. Okay. So yeah, node 5 lower bound value is how it is calculated. Please listen clearly. See, for node 5, I am assigning job 1 to person B. So person B means second row. Go to second row. Okay. So in the calculation, I am using 4 terms. First term is related with person A. It is already fixed. C, it is 1 comma 2 only. It is fixed now. Means second job for first person. First term is always C 1 comma 2 for this example. Plus, now second term is what? Second term is related with person B. So person B means second row. Observe the second row. So in the second row, I am going to assign job 1 to person B. If I assign job 1 to person B, what is the cost? 6 now. Okay. So 2 plus 6 plus, for the remaining 2 persons, as usual, take the smallest number from the next 2 rows. Such a way that those 2 numbers should not come in the same column which is already assigned for the other persons. Okay. So 2 plus 6 plus person C. For person C, the number smallest number is the third. You observe the third row. Smallest number is 1 now. So 1, yes, 1 I can take, because the column 3 is not given for any persons. I can take 1 plus person 4, smallest number is 4. Yes, you can take 4. The cost becomes 13. Okay. I hope the calculation is clear. If it is not clear, you see the next calculation. Node 6. Node 6, how it is calculated? First term C1 comma 2. It is fixed now. Second term is you assign job 3 to person B. Job 3 to person B means in the second row. I am talking about person B now. See the second row. In the second row, if I assign job 3 to person B, what will be the cost? It will be 3. So 2 plus 3 plus. For the remaining 2 persons, what I have to do? Taking the smallest number in the next 2 rows. Okay. So the third person, person C, smallest number is what? 1. Actually, it is 1. But I'm not going to write 1 here. I have written 5. Why? Again, the reason remains same. If you write 1 here, 1 is coming from the third column. Third column I am using for person B. So 1 should not come in the same column. Leave 1, take the next minimum value. Next minimum value is 5 now. You can take 5. Person D, smallest number is 4. Yes, you can take 4. Cost is how much? 14. Let me to explain node 7 calculation. For node 7 lower bound value, how it is calculated. First term, it is fixed C of 1 comma 2. Second term, I am assigning means person B. See the second row. Fourth job is assigned for person B. Its cost is 7. 2 plus 7. For the next two members, 2 persons, choose the smallest number in the corresponding rows. So person C, smallest number is 1. Yes, 1 I can take, because third column is not given for any other persons. So 1 I can take plus. Now observe the person D. Person D, smallest number is 4, but actually fourth column now I am giving for second person, person B. Okay, I am not supposed to take 4 for the person D. I should go for the next smallest number in the fourth row. What is the next smallest number? It is 6. 6 actually, yeah. It is next smallest number is 6 actually. but I am not supposed to take 6 also. Why? Because second column is already fixed for person A, no? For person A, I have given job 2. So I am not supposed to take the smallest number for person D from the second column also. So if you leave 6, what is the next smallest number? 7. Okay, take 7. Now add these numbers, sum becomes 17. So cost of the node 7 is 17. So 5, 6, 7, 3 nodes are explored when I try to explore node 2. Okay, cost is 13, 14, 17. Among these three, which one is best? Node 5 is best because cost of node 5 is 13, which is minimum compared to 14 and 17. Now in the next slide, I am going to explore node 5. So tree is expanded now. So now up to now, okay, till now we have assigned 2 jobs to 2 persons. One is second job to person A and first job to person B. It is fixed now. Now I have only 2 jobs left and 2 persons are there. Just I have to assign jobs to person C and person D. Okay, we'll do it in the next slide. Okay, now for your reference, I have given the cost matrix. Now in the right side you can see the partial state space tree started with 0, moving to node 2 is the best one. From 2 to I am moving to node 5, this is best one, and remaining nodes are the non-promising nodes. Now I'm going to explore node 5 now. So when I explore node 5, I can assign job to person C now because AB is over. Now I have to assign job to person C. See, when I assign job to person C, only one job is left and one person is left. That is person D. So in node 8 and node 9, I am doing calculation for both person C and as well as for person D also. Because if I give job 3 to person C, obviously I have to give job 4 to person D. Or if I give job 4 to person C, I have to give job 3 to person D because I have only 2 jobs left. Job 1, job 2 is over. So only job 3 and job 4 is left. So if you give job 3 to person C, you have to give job 4 to person D. And that calculation is given in node 8. If you give job 4 to person C, if you have to give job 3 to person D, and that calculation is given in node 9. Okay. Now let me re-explain the value of node 8 and node 9, how it is calculated with this calculation. Okay, this is the calculation of node 8. Okay, observe here. First term in this sum is C of 1 comma 2. Why? It is already fixed. Second job for the first person, it is already fixed. Okay, second term is C of 2 comma 1. Why? Because job 1 is given for person 2, that is person B. The first 2 terms are fixed now. It is 2 plus 6 only. For see the next 2 terms. C, I am giving third job to person C. So the calculation is 3 comma 3 means person C means third row. Third job means third column. So C of 3 comma 3. C of 3 comma 3 is how much? 1 plus. Now person 4 for person 4, job 4 is given for person D. So what is the cost now? C of 4 comma 4. Why? 4 means row 4 means person D. Column 4 means job 4. So C 4 comma 4 is 4. Cost is how much? 13. Okay. Now let me explain how cost of 9 is calculated. So one more possible option. Okay. First 2 terms it's fixed already. C of 1 comma 2 plus C of 2 comma 1. Suppose if I give job 4 to person C, then the value will be C of 3 comma 4. Why? Third row means the person C. Fourth column because fourth job for person C. So C of 3 comma 4, it is how much? 3 of 4 comma 4 is 8. Okay. And C of 4 comma 3 means you are giving job 3 to person 4. So fourth row, third column, how much it is? 9. So the cost will be 25. So cost of node 8 and node 9 is calculated. Now I have assigned all n jobs. Okay. And I have completed the assignment problem now. So n jobs assigned to n persons now. Okay. So now observe, compare 8 and 9. Which one is best? Node 8 is best. Cost is 13. Now I am going to treat node 8 as the solution. Node 9 is also solution, but it's not the optimal solution because it is taking 25 cost, and node 8 cost is 13. Which one is best? Node 8 is best. This is node 8 is the optimal solution now. Okay, so this is what the method of solving job assignment problem using branch and bound technique. For today's class, this is enough. Okay, the next example is knapsack problem. We will discuss knapsack problem in the next coming class, but my suggestion here is you practice this problem and listen my explanation. I am going to upload this presentation link in the Google Classroom. Please observe this video 2 or 3 times, then you solve the same problem again and again. Okay, so it's very important that selecting the cost for the cost values from the cost matrix is very important, because we have to choose the cost without violating the problem constraints also. That's why. Okay, so this is what the solving job assignment problem using branch and bound technique. So now let me to stop for today's class discussion on this topic. If you have any doubts here, I will come back to this presentation again in today's class only. Okay, now let me to leave this sharing. Okay, so let me to move to the meeting again. Okay, stop sharing. Okay, now it is open for a discussion. If anybody are having any problems or doubts, you can ask. So when I started the class, it was 46 attendance. Now it is 40. Don't know the reason. Yes. Any doubts? Yes, Anusha?
No, sir.
No doubts?
No, sir.
Is it clear completely or?
Yes, sir. It was complete.
Okay, you practice it once again.
That
Yeah,
subset problem was asked by me.
yeah, correct. Yeah, now it's clear. Your doubt is clear now. I have clarified that doubt. It's
Yes,
clear, no?
yes, sir.
Okay, fine. You take one more set, and try to solve one more example. Okay.
Okay, sir.
I will post a few more examples in the Google Classroom. Okay. Hmm?
Yes, sir.
Okay. Next. Any other? I think now your doubts are clear, no, Anusha?
Yes, sir.
Okay. Now chance. Let me give chance for others. Okay. Let me stop this recording now. Stop recording.